Okay, so in this video we're going to try and find the inverse function of y equals sinh of x. So basically what we're going to do is basically transform this so it's in terms of x rather than y. Now what we want to do is try and find it without a trigonometric function. So the easiest way to do it, if you don't mind the trigonometric function, is to just take the inverse sinh on both sides, just like this. And then what happens is these two terms cancel out, and then you're left with x equals inverse sinh of y. And that's a really easy way, but that would be really boring just to go with that. So for this video we're going to try and find x without using trigonometric form. So one way to do that is we go into exponential form. So we know what sinh of x is in terms of exponential. So what we can say is that y equals 1/2 e to the x minus e to the minus x. So this is still the same value as what this is. Okay, so now we've got all our terms here now are within indices of the exponential function, which is still not really helping us very much. So let's do a little substitution to get rid of these e to the x's. So if we let t equal e to the x, that takes care of this one. E to the minus x, well that's just 1 over e to the x. So that will then just give us 1 over t in terms of our substitution. So let's plug that into there. And while we're at it, we can multiply both sides by 2 to get rid of this half. So then we've got 2y, so that's multiplied by 2. Now multiplying this side by 2, this cancels. And then we're left with our t minus 1 over t. So you can see where these ones come from. And this one here comes from this one here. So if I just write that one there is e so equal to e to the minus x, then that's nice and clear. Okay, just got an awkward fraction in here. So if we try and get rid of this, we multiply through by t, that will get rid of this, multiply this by t, and multiply this by t. So effectively, just multiplying the whole thing by t. And here, I could have put a bracket around there to show I'm multiplying by 2. Okay, let's multiply through by t. So now we've got 2yt equals, distribute this t to here, we get t squared, and then this t to here, t over t is just 1, so that just leaves minus 1. Okay, so now it looks like we're getting into a quadratic equation here. So if I bring this 2yt over to this side, I'll end up with t squared minus 2yt minus 1 equals 0. Now this will not factor, so I'm going to need the quadratic formula. So let's write that up there. So we're looking to solve in terms of t. So t equals minus b plus or minus square root b squared minus 4ac, and that's all over 2a. Now in terms of this formula here, our coefficients are a equals 1, so that's the coefficient there. This one in terms of t is the 2y, and it's a minus 2y. And the c here is a minus 1. So let's just plug them into here, see where that takes us. T equals minus b, so that's plus 2y, plus or minus square root, b squared, minus 2y squared, y becomes squared, and the minus 2 becomes positive 4. So that's 4y squared, and then 4ac. 4 times 1 is 4, times minus 1 is minus 4, and then another minus here, so that then gives us plus 4. And then the 2a, 2 times 1 is just 2. Okay, so we got a 2 here, a 2 here, a 4 and a 4 in the radical here. So if we take the square root of 4 out of this, we're left with a 2. So therefore we've got t equals plus 2y plus or minus, and then we've got square root of y squared plus 1, and then the square root of 4 comes out, which then gives us a 2, and then divide that by 2. Okay, so now we can cancel all of these 2's. So then we're left with t equals y plus or minus square root y squared plus 1. Okay, that's a little bit easy to work with. So we've got this in terms of t, but we want it in terms of x. Well, t equals e to the x. So we can stick an e to the x in front of here. Okay, so e to the x equals y plus or minus square root of y squared plus 1. So the x is still in the exponential term here. So what we need to do is take the logarithm on both sides, thus getting rid of the exponential term here, getting x on its own. So if we go like this, take the logarithm. So ln of e to the x just becomes x. We won't worry about the t, that was just our dummy variable. And then log of this is simply log of the whole thing. Now we don't know if this is positive or negative at the moment, so we need the absolute value. So y plus or minus square root y squared plus 1. Okay, now this y squared, square root of y squared plus 1, and the y added onto it, if we subtract from it, we could end up with a negative. Now we don't want that in our logarithm because we're into complex numbers. So as e to the x, so e to the x is always greater than 0, what we'll say is we'll just get rid of the negative term and just use it in terms of the positive. So there our answer will be x equals natural logarithm y plus square root y squared plus 1. And that will be our answer. Okay.